Okay, today's topic is kind of the culmination of all the work we've done. Um, maybe you'd agree with me. Hopefully you will. That a lot of what we've learned so far this unit actually wasn't new. A lot of it is actually 10C curriculum. But one thing that I really try to be as a teacher is very thorough in reviewing previous concepts, so that when it comes time to introduce a new concept, the groundwork is well laid. I think last year I used the Jenga tower analogy with you guys. I believe that a lot in math. If you have a broken bottom layer, you can't build on top of it. Okay, so this is really the focal point now of what we've been working on. Both curriculums, dash one or dash two, is to get you to this point here. I want to teach you guys how to solve a radical equation. Okay, but in order to do that, it means we have to have a thorough knowledge of how to work with radicals in general. Okay, so here's our goal. I want to continue what we were doing in our last section, which would have been how to solve quadratic equations or how to solve rational equations. We're going to continue with the solving concept, only now the equations we have are going to have square roots. Okay. If I could, I'd like to actually just do a quick recap on how to solve other types of equations before I get there. Let's do a new slide. Let's say that I give you a linear equation. Do you guys know what I mean when I use the word linear? That would be like 3x plus 4 equals 9. How do you solve a linear equation? This is back to like junior high algebra. What do you do? What are the steps? Go ahead. Say it out loud. It's fine. Subtract the 4, I'd say probably. So that would give you 5. And then divide by 3. Okay? So this is junior high algebra. That makes sense to everybody? Okay. So that's one kind of equation you guys have been learning how to solve. Second kind of equation. What if I give you something quadratic, which would be like, say, x squared plus 3x minus 2 equals x squared plus 7. What's different about quadratic equations? What do you have to do differently? Make one side equal to 0. You guys catch that? You always have to make one side equal to 0 for this to work. So I would probably, in this example here, bring everything this way and make it x squared plus 3x minus 9 equals 0. And then you have two options. Option 1, you can factor, if you can actually factor, or option 2 is the quadratic formula. Does that make sense? I don't think I can factor this. I don't think I'm going to find numbers that equal 3 or 9, so I'd probably do something like this. A is 1, C is minus 9, and that'll give me my answers. I don't know if you guys have been realizing this, but this is what we've been building to the whole way through the year, is how to solve new types of equations. So linear equations, quadratic equations. Another type of equation that you guys had to work on solving was a rational equation. This would be something like x over x plus 2 equals 7 over x plus 1. What's the key step in order to solve a rational equation? What do you have to do to both sides? You're right. What do you call that? What is this? Yeah, cross multiply. Right? At some point, you're going to want to cross multiply. Right? And then one of the interesting things about rationals is when you get to a certain point, it's no longer rational, but now it's quadratic. What happens when I FOIL this out? I get x squared plus x. I get 7x plus 14. Isn't this just back to being quadratic? And really, that's that Jenga tower analogy. If I can teach you how to solve a quadratic first, then when I teach you how to solve a rational might involve a quadratic. You know what I'm saying here? Well, we're now adding the next layer on top. What if I give you equations that now involve, here we go, square roots. Okay, so that's my goal today, to show you how to solve these guys here. If I can go back to this slide that's way too small to read now. Here's our goal. In order to solve a radical equation, radicals are square roots. The real key here is that you got to square both sides of the equation. One thing that hopefully I've done a good job of explaining to you is that the opposite of a square root is a square sign. Just like adding has an opposite of subtracting, multiplying has an opposite of dividing. The guys in the other room over there, they're currently learning that exponents have an opposite in logarithms. We'll get to that one day. Well, a square root has an opposite in squaring. So how do you undo a square root sign? square. But you have to square both sides. So, here's another thing I got to point out here, is that just like with our quadratics, it's actually possible, just take them by hand, I guess. It's actually possible to have 1, 2. It's actually even possible to have no answer still. And this throws kids because they get really frustrated that they've done all this work and then they discover that there is no solution. But I have to let you guys know, in the real world, as well as in math, sometimes the answer literally is, there is no answer. Let me give you actually like a purposeful one from physics. Okay, some of you guys will take physics with me next year. Imagine, why does it keep doing that? I want a new slide here. Imagine that you were to throw a ball up in the air. Let's say I were to ask you, when does the ball get this high off the ground? How many times does the ball get this high off the ground as I throw the ball up in the air? Well, look, it actually ends up being that high up in the air twice. Kind of like quadratics, sometimes there are two answers. The ball is that high on the way up and on the way down. But if I were to ask you, when is the ball this high up in the air? The answer is, it isn't. You know what I'm saying here? So sometimes the answer literally is, that's impossible. Right? And sometimes in math, kids find this frustrating because you guys have been led to believe that there's always an answer in math. But that's not true. Sometimes there are problems where if I ask you to solve it, the answer is, well, you can't solve it. You guys have already seen this before in other random things. Like, for example, what if I ask you to solve this equation? What's the answer to that? Well, we can't. You're not allowed to square root a negative number. Or if I ask you, solve this. Again, what's the answer to this? I can't. Because according to some rules and properties that we have, you can't divide by 0. You can't square root a negative number. Or if I ask you to throw a ball up in the air, and I ask you, when will it be this high? The answer sometimes is, it's not. So I need to forewarn you guys, in this section here, still be prepared for either one answer, because it's a linear solution, 2 answers, because it's a quadratic solution, or possibly the answer, there is no answer. Fair enough? Okay, let's try some examples. So here's the first ones I have. Now, when I teach my students, I know I didn't get to teach you guys a lot in the rational section, but I always like to use an analogy, and I think kids like it because they can picture this. Has anybody ever seen Pirates of the Caribbean movie with Johnny Depp and you guys know the movie I'm talking about? Okay. There's a moment in the first movie. Sorry, side tangent here. I promise I do have a point. Okay. There's a moment in the very first movie where he's got to shoot a bullet at his old buddy who's now undead, if you know the movie I'm talking about. And Johnny Depp's character says to him, wait for the opportune moment. Do you guys know the line I'm talking about? And he finally does shoot him only once. Finally, once that curse is broken, then he finally shoots his undead old captain that marooned him. You guys know the scene I'm talking about? You don't know? I gotta find this. We gotta remember. The phrase that I want you guys to remember in math here is this: wait for the opportune moment. Okay? Because sometimes kids get a little ahead of themselves and they say, "Hey, I'm gonna square stuff." Okay? Because really, that's how you undo a square root. You square both sides. But my advice to you is this: wait for the opportune moment. Don't go squaring just at any point. Wait until the most effective time to do that. So if you're in the movie Pirates of the Caribbean, wait until the undead pirate is now alive, and then shoot him, if you know the reference I'm talking about. So right here in the first example is actually totally the opportune moment. See how I have a square root on this side right here, and a square root on this side right here? This is an excellent time to apply the operation of squaring to both sides. If I square this side here and square this side here, is that not fair to do it to both sides? Because, I mean, I could add to both sides. I could subtract both sides. I could multiply, divide, right? But I have to make sure I do it to both sides. What happens when you square a square root? Like, literally, it goes away. Right? So now what we're left with is 3x plus 1 equals 2x plus 3. What kind of equation do we have? Linear or quadratic? Linear. Why is this linear? There's no squares, right? Nothing. There's no x's that are squared. So how do you solve a linear equation? Collect like terms, basically. Like bring all of your x's to one side. So maybe like do this. So that'll give you 1x plus 1 equals 3. Subtract 1 from both sides. There, x equals 2. Not so bad. But you guys probably know how I teach. I always build our way up, right? This was the opportune moment to square both sides. Let's try the next example. I want to show you what some kids do incorrectly. They think, well, here, I'm just going to start squaring everything. That's not right. Because the way that you apply something is that you have to square an entire side, and you have to square an entire side. Okay? I can't just randomly start throwing 2's everywhere here and squaring stuff. That's actually not mathematically equivalent. So I have to, again, wait for the opportune moment. And we're not quite at that opportune moment yet, because why don't I combine some like terms first? Watch this. See how there's an 8 on this side right here? There's a -2 over there. Those are like terms. Before I get to the squaring part, why don't I add 8 to both sides? See how now that -8 and +8 is gone? And what I'm left with is 6 equals root 3x. I'm going to say this a lot today. This is an opportune moment. This is the right time to square both sides. Before was really not a great idea, but now this is a great time to square both sides. Because if I square this side and this side here, let's talk it through. What happens when you square 6? 36. That's pretty easy, right? What happens when you square a square root? It just goes away. So you're left with 3x. Can you guys see how that was the opportune time to square both sides? Well, all I got to do now is just divide by 3 on both sides. X is 12. So let's talk about this one here. This guy here, we're not quite at that opportune moment, because some kids might think, hey, square roots, let's square both sides. But doing this is actually not mathematically correct. You can't square things individually. You have to square an entire side. So then some kids, they get a brilliant idea and they say, hang on a sec, well, why don't I do this? Don't write this, by the way. They'd say, well, why don't I put a bracket around it, square that entire side, and square that entire side? That's actually valid. But my suggestion is, that's not really the opportune moment. Because what does this right here mean if you write it all in brackets squared? It means to FOIL it, yeah. It really means to write 2x minus 5 square root plus 4, and then a second square root 2x minus 5 plus 4. And in theory, sure, I could FOIL this thing. That's a lot of work. Opportune moment. Watch this instead. What if I were to try to isolate the square root sign and subtract 4 from both sides? Do you see how all of a sudden this plus 4 is now gone? Now what I'm left with is 2x minus 5 equals x minus 4. I know it's a little tweak, but this is now the opportune moment to square both sides. Because watch what happens. Let's say I square this side right here. When you square a square root, literally it goes away. How do I properly square this side right here, though? Well, I have to like put the whole thing in brackets, square all of it, but this is just foiling, isn't it? Don't miss the middle terms, by the way. This means you need x squared minus 8x plus 16. Let's just show you that in case you missed it. X minus 4 and another x minus 4. If you FOIL it out, this gives you x squared. That gives you 16. But don't forget about those middle terms. You gotta take off? Okay, just go ahead. Do you guys see what I mean by wait for the right moment? What I really want you guys to work on here when you're solving these ones is wait for the time when it's best to square root both sides. Don't just see square roots and go, hey, I can square root. I can square both sides. Wait until it's the most effective. Okay. At this point here, what kind of equation do we have? Quadratic. Can you guys see why we had to learn quadratics before we learned how to do radicals? Right? We would have learned this last year, but last year you guys hadn't really learned how to do quadratics yet. So, how do you solve a quadratic? What's the base requirement? What do you have to get? Everything, one side has to equal 0. So, throw everything this way here. You want x squared minus 10x plus 5 plus 21. How many answers can a quadratic have? Up to 2. This is x minus 7. This is x minus 3. I actually now have two answers, 7 and 3. I blew through the last two steps a little bit fast, but you guys able to handle the quadratic part of this? Okay, one thing though. A good mathematician, you guys are all good mathematicians because I'm your teacher. You guys need to check your work. You always have to check your work. I want to show you something here. Let's say that I check just because you're like, hey, I want to make sure it works. Let's try 7. 2 times 7, that's 14. 14 minus 5 would give you 9. When you square root 9, that would give you 3. And 3 plus 4 would actually give you 7. So it looks like 7 actually works. But I got to show you this because this happens once in a while. What happens when I try 3? Where's my eraser? Try checking the number 3. 2 times 3 would give you 6, right? 6 minus 5 would give you 1. So then you square root 1. When you square root 1, it gives you 1. 1 plus 4 gives you 5. But wasn't it supposed to be equal to 3? This happens once in a while. This is one of these things. Hopefully Quan taught you this. It's called an extraneous solution. You always, when you're working with fractions or square roots, you have to check your work. Because sometimes you pull like a phantom answer, an answer that you didn't make a mistake on. Like every piece of work you did there was correct. But when you go back and check it, somehow it doesn't actually work when you recheck it the first time around. We call those extraneous solutions. Did he use that word with you guys? Okay. I'm going to write it down here so that you guys are clear on this. We call them extraneous. I mean, literally that's where the word comes from. Extra solution. Extraneous. Okay. It's an answer that you get, but when you check your work, it's not possible. Okay. It's actually really challenging for me to describe to you how extraneous solutions come to be. The best example I've ever come up with was this. You guys ever know about how, like, say, Army vets, say someone ends up being in Iraq and, like, say their arm gets blown off? Sad story, okay? But you ever hear these stories about how they think they still have their arm? And, like, their mind still believes that it's there, but it's not? You ever heard of this kind of stories before? Some of you are nodding. Where, like, they're missing a limb, but their mind doesn't know that they're still missing a limb, and so they still think, they still feel pain in an arm that doesn't exist. Ever hear these stories before? Like an amputee, perhaps, where the amputee has lost their leg, and they still feel a phantom pain in their leg, even though their leg is not physically there. Some of you are nodding. Okay, that's the best analogy I've ever found for an extraneous solution, is that I have two answers here, just like I have two limbs, and yet one of them actually doesn't work. All right, and so I know the analogy is not great. Okay, maybe you get where I'm going here, though, is that when you go back and you check your work, the 3 actually didn't fit. So you actually only got one solution here. Okay. Okay, let's try another example. That's actually what my next slide is about here. It's about this idea of what if you pull an extra solution? And kids find this frustrating because they're like, Chris, for 11 years of work, not only have I been taught that there's one answer, and there should be one answer, but now you're telling me there could be two answers, or no answers, and now you're telling me that I might do all of my work properly and still get a wrong answer. So kids find this quite frustrating. Long story short, make sure you check your work. Here's kind of the example I had, right? When we check 3, and this side right here, somehow 5 would equal 3. So that means that this is not a true answer. We're going to pick these phantom solutions up, just kind of like you get like phantom pain in your amputated leg, in anything that's radical, rational, and next year when you guys are in grade 12, you're doing what they're doing over there. When you guys eventually do logarithms, these are places where sometimes these extra answers are picked up. So, long story short, check your work. It doesn't take more than a second or two, but you should always double check. So let's try some more examples now. Again, keep in mind my Johnny Depp Pirates of the Caribbean kind of idea. Wait for the opportune moment. both of these ones here require squaring both sides, but let's wait until the right time. For example, on this one over here on the left, is now the right time to square both sides? What could you do? You seem to have an idea there, Daniel. Yeah, why not divide both sides by 3? That's a pretty easy thing to do, right? Divide both sides by 3. It would leave you with the square root of 3x plus 4, but now it's going to equal negative 3. Now's a great time to square. Basically, because this square root is isolated. Because it's by itself, let's pick it off. So let's square this side. Let's square this side. When you square root 3x over 4, squared and square rooted, I mean, it literally just becomes 3x over 4. That's easy. What about negative 3 squared? Say it. 9. Positive 9, though, right? What kind of solution are we going to get here? A linear one or a quadratic one? Do we have x's or x squareds? Just x's. So why don't we times the 4 up over here and make it 3x equals 36. Divide by 3, x actually equals 12. But I know I can see a couple of you guys are ahead of me here. Check your work. 3 times 12 would give you 36. 36 divided by 4 would actually give you 9. Square root 9, it gives you 3. Long story short, all of this right here would be 3. Times that by negative 3. Uh-oh. We got positive 9. And maybe this helps to explain that phantom solution. Here's the reason why we got the wrong answer. And there is no answer, by the way, to this. This is an unsolvable question. You know how when we had negative 3 right here and we squared it? It gave us positive 9. This is the reason why sometimes you pick up a phantom answer, is that when you have a negative times by a negative, sometimes it gives you a positive. Well, not sometimes, it always gives you a positive. And sometimes that changes how things work then. You know what I'm saying here? Because of the fact that this was a negative that we squared and it made it a positive, it made that this answer right here was going to be positive. But there is no way that this is going to work because a negative number times by this can't give me a positive. See the issue here? So, long story short, after all that work, there is no answer. There is no number you can plug in for x that will make this work. And again, kids find that frustrating because they're like, why did I do all this work? Fair enough. I don't know. I'd answer with that, right? It's not about the answer sometimes. It's about the mental processes of practicing new skills. Okay, let's try another one. Is this the opportune time right here to square both sides? Not yet. It's close, though. Why don't we add 2 to both sides? If you guys can kind of visualize this, if I add 2 to both sides, now I've isolated, let me just put a line down here. I've now isolated my square root on this side. Well, then if I square both sides, on this left-hand side right here, I'm literally left with x minus 3. Here's where we may pick up that extra answer. You know how when you square this side over here, any negative numbers that were in there would now become positive. And sometimes that's why you get that extra phantom solution, the extraneous solution. It's because of this step right here. It may or may not happen, though. Like, there's not always an extra one. Okay, what happens when you square this? You get x squared plus 4. But there's more than that, right? Don't forget, this really means x plus 2 next to x plus 2. So don't miss the fact that you got to do those middle terms. So there's also a 4x sitting there as well. Some people miss that when they FOIL this out. Linear or quadratic? Quadratic. So we solve quadratics by making both sides equal to 0. So you're going to have x squared plus 3x plus 7? Yeah, x squared plus 3x plus 7. Can you factor it? No, you can't factor it. Because you need numbers that add to 3 and times to 7. I don't think this exists. How do you solve this then? Use the quadratic formula. Now, if it's okay with you guys, though, can I save some time and just say, you guys know how to use the quadratic formula, right? Okay. So I would just say, use the quadratic formula. You're either going to get one answer, two answers, or it's actually possible that you get no answers, right? But that's how you get your solutions. Whatever those answers are, though, don't forget to replug them back in for x just to see whether or not they actually work. You guys can see why we had to do quadratics first, though. Does this kind of explain why I had to put the hardest unit first? It kind of stinks because we had to put that rationals unit first, but the rationale was, the rationale for rationals is that before I could do this section, which most kids find easier, we had to learn the quadratic formula first. So hopefully that explains my reasoning. Okay. How many more slides do I have for the kids in Dash 2? We're almost done that section, right? Okay, why don't I skip through and pick a couple different ones here. Let's talk through this one here, just because there's a trick to it, or a twist. We're actually already at the point right now where it would be worthwhile for us to square both sides. And it means that you're going to get x plus 2 next to another x plus 2, and that's going to equal 5 x plus 2. Does anybody see what I'm going for on this one here, though? Something can cancel. Yeah, right? This x plus 2 squared means literally I have two of them next to each other. You guys might have noticed, though, I didn't FOIL it out. The reason I chose not to FOIL it out is because I recognized, hey, look, there's an x plus 2 over here. So in theory, what I could do is I could try to cancel this one with this one. And what I'm left with now is x plus 2 equals 5. Minus 2 from both sides, x is 3. Is that nice and quick? So that's the reason why I put this one on here, is that most of the time, this piece right here, you're going to want to FOIL it most of the time. But once in a while, it might actually be better to just not bother FOILing it. Maybe you should just cancel it if you can on both sides. If you can. Let's skip ahead to this last one here then. And then the kids who are in Dash 2, you can kind of tune out a little bit. Because I think this is the end of those ones. What about this one here? Is this really that different than what we've done before? What does the exponent of 1/2 mean? Square root, right? You guys remember this, right? If you have x to the 1/2, it means that it is a square root. If I give you x to the 1/3, it means it's a cubed root. So if all of this is to the 1/2, really it just means that you have the square root of 4x plus 8 over 2 equals x minus 3. Now, some kids on this one, most kids, would actually say, okay, why don't I get rid of the 2 by timesing it up there? And actually, I have no problem with that. But I want to show you something really clever on this one. You know how I was saying earlier, wait for the opportune moment? I have an even better opportune moment than timesing the 2 up. I'm going to utilize a skill that we've worked on before. 2 skills, really. I'm going to take the stuff inside the square root right here. I am going to factor it, and then I'm going to reduce it. And I just saw a couple of you have a brainwave. What happens when you factor this right here? What do you get? Well, if you factor it, you get 4x plus 2. Are you okay with that part right there? If I factor it, I get 4x plus 2. Now, one of those can be square rooted. You can't square root the x plus 2, but can you square root the 4? What does 4 square root to? 2. So really, this was all the time it was over 2, right? But if I take this 4 and I pull it out, which you can kind of see, this is why I'm teaching it in the order that I am, you can then pull the 2 out front, leave the x plus 2 behind, but hey, look, I'm dividing by 2. You guys see the whole trick behind this one here? Rather than times this 2 up over here, you may, once in a while, find it useful to factor the inside, pull the number out front, and then hopefully you see where I'm going here. Cancel those 2's. Isn't that brilliant? Now is the opportune moment. Now when I want to square both sides, square this side, square this side. Here you get x plus 2. again, here, don't forget to make those middle terms, right? When you FOIL this stuff out, you're going to get x squared minus 6x plus 9. What kind of equation is this now? Quadratic. All right, so just solve using quadratic means. So I'll shut up now and just solve it. Let me know if I lose you, okay? So it looks to me like I need the quadratic formula for this one, which again, you can kind of see why we had to do the quadratic formula first. I get this when I'm done. There's my two answers. I got 7 plus or minus root 21 over 2. Everybody else get that? You got that too? Okay. One last thing you should always try. You should check your work. When you get a quadratic formula, it kind of stinks because you have to really type it in all as one exact value. So what I might do is 7 plus the root of 21 divided by 2. Have I ever shown you guys how to store a number in your calculator? Okay. If I haven't, it goes like this. Go store right here, and then like pick a letter, like say A for it to be. And now this value is A. So then when I want to use this equation here, I can do this. I can go bracket 4 times that answer. That's not right. That answer plus 8 all to the power of a half divided by 2. And then do A minus 3. And if both sides equal each other, we're good. However, that was only one of the two answers. The other quadratic formula one, thank you, is, what's it going to be? It was 7 minus root 21 divided by 2. I'll store that one as letter B, and then let's do the same thing. 4 times B plus 8 all to the power of a half divided by 2. And then if I take B and I minus 3, are they equal to each other? You guys able to follow what I was doing there? I was checking my work. This side right here gave me positive 1.79. This side over here, though, gave me negative 1.79. So you know how when you do the quadratic formula and you have the plus or minus root 121 over 7? When I did the minus one of them, apparently that didn't work. So it's actually just 7 plus root 21 over 2. You always need to double check, and it sucks when you get the quadratic formula because you have to like find this number as a decimal and plug it back in. You got to find both of them as decimal numbers and plug them back in, which kind of stinks. So. Was that the last slide on your notes there? I think I just have like a word slide here. Okay, so let me summarize, and then -2s you can kind of tune out here. So here's kind of a summary then. How do you solve radical equations? Okay, the real key here is that you need to square both sides of the equation. Okay, for you guys that are in my -2 class, for the most part, what I covered here is at least where the bar is set, probably even lower than that. Okay, so long as you can square both sides and remember to check your work, you're good. But for you guys that are in my -1 class, there's a few more twists and tricks that I need to make sure I show you, which includes things like working with fractions, conjugates like we did last day. So does this work right now? If you guys are in my -2 class, feel free to kind of tune out and work on your own stuff. For everybody else, I've got a few more examples I want to show you on some challenging questions. So Here's dash 1. What is different about this example here now? There's 2 square roots. So you might think to yourself, okay, Schalk told me that I should isolate a square root and get the square root all by itself. How do you get one of these square roots by itself? Can this square root go with that square root? Why not? They're not like radicants. And so if you're in my dash 1 class, the extra twist is I might give you a question like this where you actually have multiple square roots. Here's how you solve it. I'm sorry, you're not going to like me. This sucks. What you do is you pick them off one at a time. Hopefully you'd agree that this guy over here is already by itself. So I'm going to take what I can get, and I'm going to square both sides. So I'm going to square this side right here. But I have to put this entire thing in brackets right here to square it, which stinks. Because it means that what we have now is 2 plus root 3x next to another 2 plus root 3x. And that all equals 4x plus 1. You guys follow that? I have to FOIL this mess. And it really is a mess. Because watch what happens. 2 times 2 gives me 4. That's good. I like that. What happens when you do root 3 times root 3? It literally is the 3x that's there. But, this is when it sucks. What happens when you do this guy together? It gives you 2 root 3x. And when you do those ones together, it gives you 2 root 3x. Did I actually manage to get rid of my square roots? Kind of. Yeah. I mean, your reaction is about right. Yeah, kind of. This one here is gone. That's good news. You know what really sucks? Now I have 2 more. It's like chopping off one head and 2 more grow back. I got rid of 1 square root, but I still have 2. But here's the good news. These ones right here are like radicants. So I can put them together. So if I have 2 root 3x plus another 2 root 3x, I actually have 4 root 6x. Good, so you're stopping. No, I did that on purpose. Don't add the radicants. The radicants stay the same. I hope you caught that, right? Okay. Okay, one more thing. We now have a single square root sign. Would you guys agree that I finally am back to now having just a single square root sign? This is where my Johnny Depp Pirates of the Caribbean thing comes in again. We're eventually going to square the equation again. We're actually going to have to do a double squaring to solve this. But we have to wait for the opportune moment. This is not the right time yet. Because I still have this crap sitting over here, this 4 and 3x. But why don't I move it to the other side? So if I minus 4 from both sides, I now have a minus 3 over here. And if I minus 3x from both sides, I get x over there. We are getting close. Have I lost any of you guys yet? We're still not at the opportune moment, though, because there's this stupid 4 sitting here. Now, what are you thinking, Daniel? What did you suggest? You could. And there's nothing wrong with dividing by 4, but let me walk you through what that would look like. Hypothetically, you divide by 4. Now both of these are divided by 4 and working with fractions the whole way through. And who likes fractions? I'm going to put my hand down even. I have a better idea. Again, opportune moment. You got to wait for like just the right time to do this. I have a better idea. Again, I'm very thorough in reviewing grade 10 concepts because here's what I'm going to suggest you do instead. You know how often we try to pull numbers out of the square root? Put it back in. Take this 4 and put it back under the square root sign twice, which gives you 3x times 4 times 4. Right? Now you don't need to divide. See how that kind of solves that problem for me a little bit? Rather than taking this 4 that was out front and dividing this side over here by 4, take the 4 and make it from a mixed radical back to an entire radical. 4 times 4 is 16 times 3. I believe this is actually 48x. Now is the opportune moment. Now square both sides. you'll get 48x. You'll get x squared minus 6x plus 9. And at this point here, now just solve like it's a quadratic. This sucks. It's actually quite hard. So normally what I do for my kids is I say, once you can get it to a quadratic, we know how to solve quadratics, right? So normally what I'll do is I'll say, once you get to a quadratic, I'm cool if you stop there. So if you could just write it as this, x squared minus 54x plus 9, I'd be okay with stopping here and saying, you know how to solve this, right? Let's just assume you can use the quadratic formula then, because we've done really the hard stuff at this point. So this is the twist for anyone in Dash 1. You have to be able to handle a second square root sign. It's more work, that's all. How did I do on that one? You guys able to follow that? Okay, let's try another example. Okay, so again, I have multiple square root signs. Are those square root signs like radicans? No, sadly they're not. This sucks. So we need to wait for the opportune moment to square both sides. Right now is not the opportune moment. I got to pick these guys off one at a time. So what I might recommend doing is try to find some way to isolate one of these so that it's by itself. Right? Either get this one by itself or that one by itself. Doesn't really matter, but one of them needs to go by itself. Now, both are equally valid, but I think one's a little bit easier. Why don't I just take this 2 and just kind of shove it back inside? Right, I already showed you that trick, right? If I take that 2 and put it back inside, it would go back inside as a 4, which really means that I now have 4x plus 4. You follow that leap there? The 2 that goes back inside twice as a 4, and so both of these terms need to be 4x plus 4. There. Now I have this guy sitting by itself. So now's the opportune moment. Let's square both sides. This side is now 4x plus 4, and this side over here kind of sucks when you have to FOIL it. So I'm going to write it next to itself just so I can visualize it better. One of the terms will be 9. One of the terms will be 3x. But the other 2 terms will have square roots. You'll have a 3 root 3x, and you'll have a different 3 root 3x. Can you guys follow that? So one more time in case you missed it. 3 times 3 gives you 9. Root 3 times root 3 gives you this guy right here. But when you FOIL these two by each other, you still get square roots. And like I mentioned last time, this looks really bad at first because you're like, I've still got 2 square roots left. But then you look closer and you realize, hang on a sec, these guys right here are like terms. So I really have 6 root 3x. So I only have 1 square root to get rid of. But I don't just start squaring stuff willy-nilly, I wait for the opportune moment. So why don't we subtract 9 from both sides, subtract 3x from both sides. You'll end up with x minus 5 over here and 6 root 3x over here. Again, you've got that stupid 6 sitting out front. One option is to divide both sides by 6. But think through what's going to happen. If you divide both sides by 6, you're going to have fractions. No one likes fractions. Like, not even me. I hate fractions. They suck. Why not put the 6 back inside again? So you'll have x minus 5 equals 3x times a couple of 6's. 6 times 6 times 3, 108? Are any of you guys ahead of me here? When you put the 6 back in twice, 6 times 6 is 36 times 3. Is that 108? Okay. All right. And then hopefully you'll recognize we've been at this stage before. Now, finally now, is that opportune moment. I say that a lot during this section here. So for any of you who haven't seen Pirates of the Caribbean, you have to go watch it. It's a good movie. It's a good movie. Now's the right moment. Square both sides. you're going to get x squared minus 10x plus 25. It'll equal 108x. Bring the 108 back to the other side to make it negative 118x plus 25. And just to be nice to you guys, I'm going to let you stop here in all of your assessments. Okay? I'm going to assume that you could use the quadratic formula if you had to. Because you probably can, right? Okay? But it's even more work to have to use the quadratic formula at this point. That makes sense to you guys? Okay. Okay, here's another kind of example that kids in Dash 1 need to be able to solve. I still have multiple square roots right here, but it's written just slightly differently. It's not quite like the one that was before. Am I okay to move on, by the way? Did I go too fast there? I'm okay? Too fast? We'll go back? I'll leave it there for a second. Sorry, guys, stop me if I go too fast. Is everybody good? You're good? Okay. Okay, so here's another one that also involves multiple square roots. Because you guys can see clearly there's one right here and there's one right here. But the difference for this guy here is rather than them being kind of individually just kind of like sitting here and here, this one now involves, we need to actually FOIL it first. So if I do this one times this one, it'll give me 2 times x. If I do this one times this one, it'll give me minus 3. Those are the nice ones. When I do the other foiling, this one right here will give me a single root x, and this one right here will give me minus 6 root x. I lose you there? Okay, so I'll do them in colors here. In blue, this times this. See how the 2 is a coefficient? Root x times root x literally gives you x, so that's where this 2x came from. Okay, you're good on that one? Second one, let's do purple. 1 times negative 3 is negative 3. That's the other easier one. Then when I do in green here, this one right here, when you do 1 times root x, 1 times anything is just the root x. So is it the last one I lost you on then? Okay, so the last one, right here you have 2 and 3 as numbers. So 2 times 3 as numbers gives you the minus 6. This guy had a root x. This guy doesn't really have a root x, so you just kind of add the root x to it. Does that make more sense now? Okay. Again, I say this a lot. Is this the opportune moment for squaring both sides? Not yet. Can't these guys go together, though? Don't you have negative 5 root x? And if I bring stuff to the other side, if I minus 2x from both sides, don't I have x plus 3? Did I do that part too fast? Bring this and this to the other side, and put these ones together. Okay, we got to pay attention really carefully to this part right here. I still have this stupid minus 5 out front. When I bring it back inside, 2 negatives have to come inside. So I'm going to have negative 5 times by another negative 5 times by the x that's already there. Although this was negative on the outside, when I bring it into the inside, it's actually just good old 25x. You know what I'm saying there? Be super careful with that. When you bring that negative back inside, it actually becomes positive 25. Okay, we've been here before. Square both sides, so 25x equals x squared plus 6x plus 9. And again, if it's okay with you guys, can we just skip the quadratic formula part? Just so you're aware, this stinks. almost every one of these probably involves a quadratic formula. Because you can probably see where we'd go, right? We'd subtract 25x from both sides. Subtract 25x from both sides. 0 would be, sorry, what is that? Negative 19x plus 9. There's no way in the world that factors, which just means you have to use the quadratic formula. So, how many do I have left? 2? Did I blitz that one too fast, or are you guys okay on that one? Okay, 2 last ones. You guys can see that they increase in complexity, don't they? Right? Or as we're going along, I'm just throwing random square roots everywhere here, and sometimes people don't like that because it's like, oh, get rid of those square roots. Right? Any thoughts? What can I do on this one? This really combines our last 2 units together. It combines radicals and rationals. See how you have a fraction right here? What do you do with the bottom of a fraction over here sometimes? Times up to the other side over here. Yeah, that's not a bad idea. So if I do that, I have 2 plus root x. And now this sucks because I have to FOIL this mess. Ugh. So, all right, here we go. This is 2 plus root x. It equals, okay, this one times this one here is literally x. That one there gives you minus 3. This one here will give you root x. And that one will give you negative 3 root x. At first glance, some kids look at this and they go, this sucks, I got 3 roots. But hang on. Aren't all 3 of these roots the same radicand? So in a way, although there's a root x right here, here, and here, they're all like terms at least. So why don't we put all of them on the same side? Let's see. Why don't I bring, which is the best way to do this? Why don't I bring this one here by minusing root x on this side and on this side. Let's add 3 root x on this side here. And why don't I minus 2 on both sides? If you can follow my logic here, I'm kind of cleaning this up a bit. I'm going to move that. I'm going to move that. I'm going to move that. Root x minus root x would be 0. And then when I add 3 root x, that's what I'd have. And then over here, I'm going to have x minus 5. Opportune moment. Not quite there yet. Did I lose anybody there? I threw the 3 inside as a 9, squared both sides, brought the 9x to the other side. I got a quadratic. These ones always need a quadratic formula. So we're just going to stop there. Let's not use the quadratic formula. Let's just say we can solve it if we have to. I still don't know whether there's going to be 1, 2, or 0 answers. And there still could be extraneous answers, but in situations like this, this is as far as I ask you to go, because it's a lot of work anyways. Okay, last one. This one right here, I want to show you one more trick you can play. First of all, what happens when you have a 1/2? Square root, right? So you could call it 6x over root 2, and it equals the square root of x plus 1. That works. I want to show you one more trick, though. Remember how yesterday, if you were in my Dash 1, I showed you how to rationalize things? This is actually an opportune time to rationalize. Because watch what's going to happen. If I were to multiply, I'll do it in front with a new color. If I were to multiply in front by root 2 over root 2, what ends up happening here is on the bottom, I literally get 2. And on the top, I'd get 6x root 2. However, doesn't 6 and 2 have the ability to cancel? And literally just give me 3. So if I play around with this first side right here, I can actually get it to 3x root 2. Everybody catch that? I'm going to times by root 2 over root 2. Now, when I do that on the top right here, 6x literally sits out front, root 2 sits behind it, but the 6 and the 2 cancel, so literally there's no reason to have a denominator anymore. Take that 3x, throw it inside. Don't forget though, throw it inside twice. So when you throw it inside twice, you have 3x times by 3x times by 2. What's 3 times 3 times 2? 18? Yeah, 18. But it's not just 18, it's 18x squared. This is the point I want to make on this one here. When you throw a number inside, that's great, but when you throw a variable inside, it becomes 18x squared. We've gone full circle. This is literally where we started class with. That is way too early. Okay, this is where we started class. Can you guys see how there's a square root on both sides? When I square both sides, literally both square roots just come entirely off. And I'm left with 18x squared equals x plus 1. Bring those to the other side, solve with a quadratic formula. That make sense? Okay, so quick recap. The main focal point of the unit, really, if you're in Dash 1 or Dash 2, is kind of the same thing. I need you to be able to solve these equations now. The key is to square both sides. When, though? Wait for the opportune moment. Try to find the right time to square both sides, where you can remove one of the square root signs. If you can wait for the right time to do it, I find kids are much more successful. The other thought I have, though, don't forget to check your work, because it's very common you pick up these extraneous solutions where it doesn't work. Okay, thanks, guys. We're actually done now. So tomorrow and Monday, I'm going to give you work time. Tuesday's a quiz. Wednesday's the gap day. Thursday's our unit test. Tomorrow, yeah. Tomorrow I'm probably going to use you a little bit more to cover my classes because they're actually doing work time.